This is lesson 7.1, Ratio and Proportions, video notes for vocabulary and examples. Learning targets for this lesson are that you will be able to write and simplify ratios, and that you will be able to solve problems with proportions. A ratio is a rational number. We already know the definition of rational numbers, numbers that can be written as a fraction. So it's formally defined as number a over b such that b is not 0, because we can't divide by 0, that's undefined, and a and b are elements of the real numbers. So they can't be, not just real numbers, that they're actually integers. They're elements of the integers. A ratio means, okay, so using ratios. The ratio measures of angles in a triangle ABC is 2, 3, and 2 to 3 to 4. Find the measures of the angles. Well, this assumes that you know a fact which most of you do remember from middle school. We have not directly had any instruction on it, but we have had some problems that involve it. That triangles, the sum of triangles, it's actually called the triangle sum theorem. And the triangle sum theorem says the angles in a triangle add to 180 degrees. Well, I don't know what the exact angles of these are, but I know that if I have some multiplier on them, maybe this was, well, I know it's not 4, 6, and 8 because that still doesn't add to 180. But the angles have to add to 180, and there's some multiplier on these that has been reduced. I don't know what it is. So my side lengths for now are 2x, 3x, and 4x. Well, if those, not side lengths, those are the angle measures. Now, if those are the angle measures, and we know that the sum of the angles in a triangle adds to 180, then we have 2x plus 3x plus 4x having to add to 180 degrees. This is 5 and 4, which is 9x equals 180 degrees. Dividing by 9, x is 20 degrees. Well, that's the value of x, but we're asked to find the measure of each angle. Well, 2 times 20 degrees is 40 degrees. 3 times 20 degrees is 60 degrees, and 4 times 20 degrees is 80 degrees. And yes, 40 plus 60 plus 80 does add to the sum of the angles in a triangle, 180 degrees. The ratio of the sides of a quadrilateral is 2 to 3 to 5 to 7. So those are the sides. So this is not a square or a rectangle or even a rhombus, because none of the sides are the same. If the perimeter is 85, find the lengths of the sides of the quadrilateral. I know there are 4 of them. I know that the 4 of them add up to 85, but I don't know what each one is because the numbers themselves have been reduced to this ratio. So my actual sides are 2x, 3x, 5x, and 7x. Together, those add up, oh, I missed the 3x, to 85. So there's 10 and 7, so that's 17x equals 85. I'm going to take 85 and divide it by 17, and we get 5. So the answer for x is 5. So plugging that back in, the side lengths for this quadrilateral are 10, 15, 25, and 35 respectively. Those numbers should add up to 85, the perimeter. This is how we can use ratios to set up problems involving ratios where there is a total or a final sum. So angles in a triangle are common applications in geometry. Side lengths adding up to the perimeter are common applications in geometry. Next, we're going to define proportion. A proportion is an equation involving ratios. An equation of ratios, often defined as A over B equals C over D, where A over B and C over D are both ratios, or A, B, C, and D are integers. Cross products, something you probably learned in middle school, are the terms that are across from each other if we were to make an X with the ratios and the proportion. So the cross products, we have the means and the extremes. You multiply these two, and you multiply these two. And they teach you this simplistic method in middle school so you don't really have to think about it. What's really happening? Why does that work? Well, if we're thinking about this as, oh, by the way, this is AD, A times D equals B times C. If we're thinking about this mathematically, instead of just memorizing a rule, what's happening is we have two fractions, and we are trying to clear the denominator in the solving process. I don't know where the variables actually are, which of these are actually numbers, but we're trying to clear the denominator so we can solve. And in doing that, we normally multiply by the least common denominator, which in this case would be b times d. So by multiplying by b times d on every fraction on both sides of the equation, here b over b is 1, leaving us with dA, or AD. Here, the d's, d over d is 1, so we are left with CB, or BC. So mathematically, doing cross products does work, otherwise they wouldn't teach that as a method, but all we're really doing is clearing our denominator by multiplying by the least common denominator and multiplying out what's left after we've simplified. If you want, you can think of it this way or this way. Either one is good for now. So we can actually use this to solve these proportions. You can multiply by the least common denominator, or you can just do cross products. 9x will be equivalent to 2 times 24, which is 48. 48 divided by 9 is 5 1/3, but in fraction form, an improper fraction form, that would reduce to 16/3, 48 over 9, and 3 going into both of those. Dividing it by 3 would give us 16/3. Letter B is a little trickier. We have to be careful here because we have not just numbers or a variable, but a variable expression. So whenever there's a variable expression involving a binomial or trinomial or even something larger, we need parentheses around that expression before we multiply. So I'm going to do the 3 times x minus 1, and that will be equivalent to 4 times the quantity x plus 1. Make sure that at this point we distribute. That's why we wanted to put parentheses around any factors or expressions that involve more than one term when they're written as a proportion. Distributing the 4 gives us 4x plus 4. Distributing the 3 gives us 3x minus 3. Now we get our x's to one side by subtracting 3x. And by subtracting 4, we get that x is negative 7. We can plug that back in to see how it works. Negative 7 plus 1 is negative 6. Negative 7 minus 1 is negative 8. Negative 6 over negative 8 does reduce to 3/4. Lastly, we have letter C. Yes, there's a decimal, but that's fine. We just have to do 9 times 18.2 and 3 times y. I might leave it like this for a second so that I can actually divide by 3. The 9 divided by 3 is 3. So really, this is 3 times 18.2, which might be a little bit easier to multiply in our head, or you can use your calculator. 3 times 18.2 is 54.6. To double check, we can put 9 over 54.6. 9 over 54.6, we get that decimal value, or as a fraction, 15/91. And we put 3 over 18.2 to see that it is the exact same decimal value, the exact same fractional value of 15/91. An application problem of ratios. Mayor Jones conducted a random survey of 200 voters, so that is our total. Found that 135 approved of the job she is doing. If there are 48,000 voters in a town, using this poll, we're going to determine the total number of voters who approve the job she is doing. Now, this is a very simplistic model, but it does use ratio and proportion to do this type of thing all the time when we poll. So the total was 200, and those who found her or approved were 135. Approved over total is a percentage. However, it's also a ratio. So I would like to know, what we're asked is, how many of her voters that live in the town, out of the total 48,000, approve of the job she is doing? Well, we have approval over total for our sample, which was 200 people, and then we have the actual. So here's our sample, and here's the actual. And the ratio is the same, approval over total, approval over total. So now we can cross multiply to get our answer. All right, so when we cross multiply, we have 135 times 48,000, and this way we have 200x. So 135 times 48,000 is 6,480,000. 6,480,000. Now we divide by 200, so I'm going to drop 2 of the zeros and divide by 2. That's going to give us 32400. So roughly 32,400 voters approve of the job she is doing, assuming that we had a random sample, and there's other rules that go into sampling. If you take AP Statistics, you'll learn all about that. Please try, before you come to class, problems 1, 2, and 3. And don't forget about lesson 7.2 video clip. Have a great day.